that'll be better. All right, so the title says Nuage Networks embraces CloudSec, and that's really the common theme of the presentation we want to give. I mean, we like CloudSec, we love CloudSec, we believe in CloudSec. We believe it's an asset for CloudSec to be well integrated with a proven SDN solution. And that's what we really want to make happen and what we're doing. Thanks to the CloudOps guys for hosting here this event in Montreal. It's really beautiful. Yeah. All right, so talking about Nuage Networks, so who are we? So we're a venture of Nuage Networks, formerly Alcatel-Lucent. So we're headquartered in Mountain View, California, and have additional development sites in Raleigh and in Antwerp. Nuage Networks is staffed with expertise in IP routing, as well as virtual compute, virtual networking. I think that's really made this unique mix really made the success of Nuage Networks. Okay. Sorry. So Nuage Networks, we bring policy-driven SDN to the cloud, and we provide choice. We provide multi-hypervisor support, so ESXi, KVM, Hyper-V, support containers. We support advanced networking for bare metals. We provide choice at the cloud management system. We integrate with VMware, with OpenStack, with CloudSec. Up to half a year ago, our CloudSec developments were mostly focused on some prime customers we had who were on a fork of CloudSec, and a lot of development effort that we did went into those private forks. But we really changed course, so we really want to be upstream. We are upstream. We are continuously delivering features upstream. We want to be really part of the community. So, yeah, so again, Nuage Networks, I mean, we believe that in order to deliver true cloud business agility, you need to have a full-fledged network virtualization and automation framework with abstraction, automation, full visibility, full control, boundaryless, and we are fully policy-driven. So looking at our architecture in a few minutes, so it's in essence a 3-layered architecture. At the hypervisor blades, we have what we call our virtual routing switch. It's a feature extended Open vSwitch. So layer 2, layer 3, layer 4 forwarding capable. We integrate with bare metal assets also. That layer is controlled through OpenFlow from our virtualized services controller layer, which are really, so they're OpenFlow controllers. And they scale horizontally through BGP. So that's where so our scaling architecture is based on BGP. So these OpenFlow controllers, they're in essence also virtual routers. We reuse the IP routing stack of the routers which are very successful, of Alcatel-Lucent, now Nokia. So there is a reuse of that software stack in the Nuage solution. And then as a layer on top, we have a policy, we have our application server, which is a policy engine, which provides all the abstraction and automation, provisioning that control layer in the middle, which gives us full control and full automation with service templates, with analytics support, and so on. So compared, so bringing that in CloudSec, what we deliver is a most optimal data path. When talking about EastWest Traffic, like direct VM to VM communication at all time. So within a hypervisor, clearly, even when VMs are placed in networks which are routed together, so not on the same layer 2 domain, but routed, the communication remains on the hypervisor. When VMs across hypervisors communicate. We use VXLAN tunneling between those hypervisors, so direct communication from the blade to the blade. We no longer have the penalty of the virtual router. Our data path is no longer relying on the virtual router at all. Even when going up to like north-south traffic, so internet-facing traffic, it's based on direct VXLAN communication from the hypervisor blade up to the gateway router. We advertise routes in that way through BGP. And we have the ability to also bring traffic directly to the underlay for some of our customers that have requested that capability. So in a nutshell again, so as Nuage, we want to bring all the goodies of SDN to CloudSec. That's really a mission. We staff features and cross-functional team together with like the core VSP developers, how we can bring that to CloudSec. We do that all together in cross-functional teams. And we focus a lot on test automation, both functional tests, including Maven for CloudSec, as concurrency testing, scale, performance testing, and so on. So how we integrate then this architecture in CloudSec. So we integrate at the level of the policy manager, which has a northbound REST API, which is a consumable and documented API. So in CloudSec, we have our Nuage VSP plugin, which through a client layer is provisioning all the functionality in the Nuage platform through that REST API. For some of depending on the network offering that is being set up, some of the control functions we rely on the virtual router. So of course that goes still. Those plugins can work perfectly together. And we did develop also a new generic plugin for public load balancing, VPC and line load balancing, which Urvi will talk about. Which provides solutions which are can be generically deployed with or without Nuage. So looking at the feature set, so we support isolated networks, VPC networks. We support since today, well, we submitted the feature PR this morning, shared networks. In terms of the capabilities, so virtual networking, obviously DHCP, user data, metadata, password reset. As of the second feature PR we submitted this morning, we have source net and static net in overlay and underlay. Network ACLs, firewall rules, internal load balancing, part of 4.9. Internal DNS also since the third feature PR, which we submitted this morning. And public load balancing through a generic new plugin, which I mentioned and which we will talk about later. So additional features which we support is audit sync support between the CloudSec state and the Nuage state to guarantee consistency and autocorrect, as well as the ability to provision templates in the VSP in the Nuage SDN platform, like advanced templates, and consume them from CloudSec. So. So we have QoS support within Nuage, of course. That is not exposed to CloudSec yet. So the ability which I mentioned to provision advanced templates within the Nuage platform and then consuming that through CloudSec, that's a way how you can do it. There's no mapping of functionality of the QoS that we support within CloudSec. So that's a matter of plugin development, which we can staff. Sorry?
Can I provision it using the CloudStack and then go down to Nuage and turn on COS as well?
So what I mentioned here, the consumable VSP domain template, is what I'm referring to. So which allows you to define advanced networking topologies, including ACLs, including QoS, and then when you instantiate the VPC in CloudSec, you can refer to to that template in Nuage, and it will link to each other. All right, so yeah, since 4.9 we have full Maven automation of the client layer, which I mentioned. It's we set up a Maven repo inside Nuage. Shared networks, as I mentioned, so that's one of the feature PRs which we submitted this morning. We do support shared networks now. It's mapped to shared subnet resources in Nuage, allows you to spin virtual instances from different CloudSec domains in a common shared network. Next upcoming is routed access, direct access to these instances, and security groups, which we don't have today in the PR, which I mentioned. SourceNet, StaticNet, we have support. So SourceNet for now is always SourceNet to the underlay for now. While StaticNet, we provide choice, either StaticNet in the overlay, either directly mapped to the underlay. So we have API support been added to enable or disable that capability of going to underlay, and it's implemented through generic VLAN details. So guest VM DNS, we support guest VM or internal DNS now. So in that solution, the Nuage virtualized service platform, so our OVS, remains the DHCP provider. The virtual router is reused as the DNS provider. So through DHCP options, we specify the DNS provider as being the virtual router. And that's how it all, how it is brought together. So we did some change in core also to make VR DNS mask entries being populated even when a VR is not the DHCP provider, but when it is a DNS provider, to make that all happen. So all of these features which I mentioned, so they're submitted upstream as PRs, including Maven test automation. One thing we discussed and which we want to propose to the community is a suggested performance and concurrency improvement on the contract between core and plugin in terms of network ACLs and firewall rules. Today, all that is done at bulk. So whenever you change an ACL or add or delete an ACL, all the ACLs are sent as bulk to the plugin, which makes it, scale less, but also it's inherently complex, because when we run concurrent tests, we see issues as of the plugin needs to find out what is still legitimate and what is outdated. So a proposed change is that the plugin can decide what it wants to receive, like the whole bulk or just the delta. And through a method which the plugin provides, core will find out how to how to interact with this plugin. So the legacy behavior will be bulk, as that's what's being used today. And for Nuage, we would go for delta. So that's we have a private internal PR right now in our lab. We're qualifying that. Looks good. So we can definitely bring it upstream if that's under interest, which we will do. So in 4.9, we also qualified internal load balancer support, so including Maven test automation. We recently found a bug in core that when multiple load balancing rules with the same source IP are provisioned, they overwrite each other. It's another PR we submitted this morning. And then, as I mentioned, we have a solution for public load balancer based on an entirely new plugin, which is a generic plugin, which Urvi will talk about. And next upcoming is, as I mentioned, shared networks with security groups. We want to support config drive for user data in isolated and isolated networks and VPC, because it would eliminate the need for the virtual router for this use case, which is which is a good thing. We have site-to-site VPN upcoming. Port forwarding is on our roadmap, as well as IPv6. So I leave the word now to Urvi. All right.
Hi, this is Urvi Shah, and I'm representing Nuage Networks, and I'm based out of Nuage's headquarters in Mountain View. And we are here to bring out our new plugin, which is called Public Load Balancing. And this is the traditional way in which the VPC VR works for load balancing. It uses the HA proxy implementation. And there are static NAT rules between the public IP and the guest server VMs. And this solution might not be feasible for SDN-backed CloudStack deployments for two reasons. The first one being the SDN solution might not have a VR at all. And the second one being, for example, if we take an SDN provider, say Nuage, the platform takes care of all the services like routing, DHCP, DNS, and the platform does it in a distributed manner, and which is different from the CloudStack way of doing it in a centralized way. So this VPC plugin, VPC inline load balancer plugin, orchestrates the load balancer VM the first time we configure the public load balancing rules. And it also takes care of its cleanup when the last public IP address is deconfigured. And this is based off the virtual VR template, which defaults to the system VR template. And we don't have the capability of changing the VM template as of now. But if need be, we can always add it in the future. So this makes it the load balancer appliance to make it very lightweight, or like make it into a heavy commercial appliance. And for this, we are adding a new concept of secondary IPs towards the appliance's guest IP. Secondary IP is another IP which is acquired in the public network, and the static NAT rules are added from the public IP to the secondary guest IP. And the subsequent public IP addresses which are acquired use the existing load balancing appliance, and only the static NAT rules are added between the public IP and the guest IP addresses. And this solution is, it serves both Nuage, which is an SDN solution, and it also serves the VR-based solution. So this serves two purposes of, like, this is our way of giving back to the community a solution which is independent of VR. And we're also contributing to the SDN world. And we already have the design spec which has been reviewed. And we're already we are coming up with a Maven test pretty soon. So this is how a VPC solution, so this is how the VPC solution looks like in a VR case. We have the virtual router which is taking care of the routing, and we have the load balancer VM out there, which is like any other guest VM in the network. And the load balancing is done through the HA proxy, and HA proxy has static NAT rules between the secondary IP and the server VMs. So this is how like a VR solution would look like VPC inline plugin. So this is a Nuage way of doing it. We have the load balancer VM in the similar way, which uses HA proxy, and it does the public IP to secondary IP static NAT using the virtual IP. So actually, I have a live demo, so I think it'll make it better. So this is how a CloudStack, this is based out of 4.9 CloudStack, and so we have the new plugin which is called the VPC inline. So this is where the network service providers are when we have the new VPC inline load balancer plugin. And if we go inside there, this is where we can see all the instances. These are the load balancer appliances which I was referring to earlier. And this is how it looks like. It has two NICs, one being the guest IP address and the other one being the control IP link. And this is where we see the public IP addresses. So if we have multiple public IP addresses, we can see all of them being configured here. I'll show you how a typical network service offering looks like. So if we go in here, this is like a Nuage implementation of VPC, a Nuage implementation of the plugin. So we have these, we have all these offerings in here. So we have virtual router for user data, and rest of the services are being consumed by Nuage. And for load balancer, we have the VPC inline load balancer VM. And I already have one which is already spawned, so we can go over it. So I already have two public IPs which are already configured for the load balancer VM, and I have like HTTP rules configured for this particular one, and I have SSH rules being configured for this one. And let's see how this looks in the Nuage setup. So this is how a typical Nuage VSD policy engine looks like. This is the load balancer VM. And these are its attributes. And here the subnet in VSD refers to the tier in the VPC. And let's go and actually look how a load balancer VM looks like. This is how the HA proxy looks like. I have two public IPs configured which have two server VMs each. And like the load balance, I mean, this mapping happens between the secondary IP and the server IP, which is addressing the request. And let's do some traffic test. I already have the system up and running, so let's see if this goes through. So this just says the load balancing is being done between the using the public IP, and I can actually add another public IP and see if the same appliance consumes the public IP and if load balancing still works. So I just acquired a new public IP and I can go ahead and configure it. So as of now, I'm just adding the HTTP rule. I'm just picking both the VMs which I have, which will service the request. I think we need to wait for it to apply. Yep, it's already active, so it's been added. Can you see the IP in there? Yeah, I can't even see. I guess, sorry? I'm not able to see the IP in there. It's okay. So, yeah, so this is how it works live in action. And any questions? Sure.
So in the list of hypervisors I saw, do you support the Zen server?
We used to support before, but we don't support anymore.
Okay.
But we might be doing it in the future. But as of now, no.
Any reasons why you moved out of Zen servers?
I guess customer requirement.
All right. Okay.
We began with Zen Server, and then currently mostly we're using VMware and KVM. So that's what we support right now.
Any more questions?
I guess that's it. Thank you, everyone.
Hold on.
Sorry.
There's a question from the online about, do you support Zen server actually? Because we saw that there is a, it was his question? Oh, sorry about that.
So we had it before, and currently we don't support it anymore. But we already have customer requirements coming up, and we might do it in the future again. So, yep.
Great. Thanks, guys.
Thank you.